Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. So today we're going to be doing Unit 7, Lesson 4. Don't forget to put your first and last name, period, and the date in the upper right-hand corner. Our main topic is transformations of exponential functions. Our objective today is I will identify the key features of exponential models and describe transformations of exponential parent functions. Mastery will be demonstrated by scoring at least 80% on the homework. So we're not going to do an extra practice today. Once you're done with the lesson, you're actually just going to jump into your homework and get your notes submitted to Schoology. Your homework is still on that. So. All right. So when I talk about a parent function of an exponential model, what I'm talking about is any exponential function in the form of y is equal to a times b to the x. So the parent function we're going to focus on for the sake of this lesson is y is equal to 1 times 2 to the x, where our a value is 1, our b value is 2. And if you recall from our previous lesson, if b is greater than 1, then this represents exponential growth. So because a is 1, 1 times 2 to the x is simply 2 to the x. So what we're talking about is the parent function y is equal to 2 to the x. And we're going to talk about all kinds of transformations that can occur to this parent function. So another example of an exponential parent function could be y is equal to 3 times 1/4 to the x. Y is equal to 0.4 to the x. Y is equal to 10 to the x. So any of these parent functions could have transformations where they're shifted up, down, left, right, reflected over the x-axis, all that good stuff. All right. So we're going to take y is equal to 2 to the x. And, since we're Algebra 2 students, why don't we use function notation? F of x is equal to 2 to the x. And let's plug in some values. Let's do like -3 to +3. So if I plug in 3, 2 to the third, 2 times 2 times 2 would be 8. If I plug in 2, 2 squared is 4. 2 to the first is 2. 2 to the 0 is 1. 2 to the -1 is 1 over 2 to the first, or 1/2. 2 to the -2 would be 1 over 2 squared, or 1/4. 2 to the -3 is 1 over 2 cubed, or 1/8. So let's plot these points. So the graph of this parent function looks like 3, 8. Let's see, 2, 4. 1, 2. 0, 1, -1, 1/2, and then these numbers just get closer and closer to the x-axis. They get smaller and smaller, but we don't actually cross the x-axis. We're going to be approaching 0 for that y value, but we're never going to reach it. So this looks like a regular exponential growth model, like what we talked about in our previous lesson. Our graph rises to the right, it falls to the left. It approaches 0, but doesn't actually touch it. So now let's talk about our transformations. So if I take this parent function and I subtract a number directly from x, so 2 to the x minus h, that is going to shift the parent function left h units. Just kidding, that's a lie. Right, it's going to shift it right that many units. When we subtract h, we shift to the right. When we add h, we shift to the left. Silly McGuire. All right. So then when I add h directly to x, so 2 to the x plus h, notice those h's are in the exponent. So in an exponential function, our x is an exponent. So if we're adding or subtracting a number directly to that x, if we're adding or subtracting a number directly to that x, then that is part of our exponent as well. So adding h shifts left h units. Okay. What about adding k to the entire function? So 2 to the x plus k. So this addition of k is not in the exponent. It's just being added to the entire function. That is going to shift our graph up h units. Then if I subtract k from the entire function, we're going to shift down. Why did I say h? I meant k units for both of those. I must be distracted today. All right, shifts down k units. And then if I take the entire function and I multiply it by a negative, that's going to reflect our function over the x-axis. So these are the only transformations we're going to talk about today. Reflects over the x-axis, and anytime you have a reflection, always do the reflection first. Always graph the reflection first. All right, so we've got our parent function, f of x is equal 2 to the x. We know what the original graph looks like. We have the points in our table here that we then graphed on this lovely coordinate plane. We know what kind of transformations we're looking for based on whether or not we're subtracting or adding a number directly to x or to the entire function. We know what happens if we multiply the entire function by a negative. Let's apply that to some examples. So for example 1 here, we're going to take f of x is equal to 2 to the x minus 4 plus 1. All right, so we've got this function. We're subtracting 4 directly from x, and we're adding 1 to the entire function. So what transformations occur here? Subtracting 4 directly to x shifts our function right 4 units. I'm having trouble with that today. And adding 1 shifts our function up 1 unit. So adding this 1 shifts up 1 unit. Subtracting the 4 directly to the x shifts us to the right 4 units. And now we're going to graph this function. So there's 2 ways we can go about this. One is we take all of these main points that we already had and we just shift them right 4 and up 1. Or we plug in some values and plot them. And that will get us the exact same thing no matter what we do. So the x values that I want to use this time, instead of using -3 through 3, like you totally can do that. Or we can adjust our values based on what is happening to x here. So because we have x minus 4, I want to use 4 as my middle value, because 4 minus 4 would be 0. So we'll have 2 to the 0 and then plus 1. So from there, we're going to do, let's do 5, 6, 7. Let's do 3, 2, 1, and 0. All right. So let's plug some values in here. So if I plug in 4, I'm going to get 2 to the 4 minus 4 plus 1. So that would give me 2 to the 0, which is 1. 1 plus 1 is 2. I'm going to plug in the 5. 2 to the 5 minus 4 plus 1 is 2 to the first plus 1, which would be 3. 2 to the 6 minus 4 plus 1. So 6 minus 4 is 2, so that would be 2 squared, which is 4 plus 1 is 5. And then 2 to the 7 minus 4 plus 1. So that would be 2 to the third, which is 8 plus 1 is 9. Then let's plug in the 3. So 2 to the 3 minus 4 plus 1 would be 2 to the negative 1 plus 1. Remember, 2 to the negative 1 is 1/2. So that would be 1.5. Then we're going to have 2 to the 2 minus 4 plus 1. So 2 minus 4 is -2. 2 to the -2 is 1 over 2 squared, which is 1 over 4. 1/4 plus 1 would be 1.25. Okay. 2 to the first minus 4 plus 1 would be 2 to the -3, which is 1 over 2 cubed. So 1 over 8 plus 1 would be, oh my gosh, what's an 8? 0.125, right? Oh my gosh, okay. 0.125 plus 1 is 1.125. I can do math, I promise. All right, and then if I plug in 0, I'm gonna get 2 to the 0 minus 4 plus 1 is 2 to the -4th. And then that's gonna be what? 1 over 2 to the 4th, which is 1/16. And then we're gonna add 1 to that. And I don't feel like doing that in my head anymore because I feel like I'm making a mistake. I'm not gonna lie. 1 divided by 16 plus 1 would be 1.06 or 1.1. Let's just round that up. I'm not going to graph 0.06. Okay, let's do 1.1. So let's plot these points. So our first point is going to be at, let's see here. When I plugged in 0, I got 1.1. So 0, 1.1. When I plugged in 1, I got 1.5, 1.125, so just a little bit above that. And 2, I got 1.25, 3, 1.5, 4 is 2. And what we begin to see is that instead of our graph approaching 0 like the parent function did, because the parent function got shifted up 1, now we're approaching 1 on the y-axis. So as you can see, these numbers got closer and closer and closer to 1, the smaller x got. So now we're approaching 1 instead of approaching 0 on our y-axis. So 4 got me 2. Okay. 5 got me 3. 6 is 5. And 7 is 9. Start to shoot up really quickly. All right. And so now instead of approaching 0, we're approaching 1. And so if you plugged in a negative number, like if we plugged in -5, so 2 to the -5 minus 4 plus 1, 2 to the -5 plus 4 plus 1 is, oh, just kidding. I did plus 4 instead of minus 4, sorry. 2 to the -5 minus 4 plus 1 is 1.001. That's the point I'm trying to make here. 1.001. Or actually, we'd round that up to 2. 1.002. So what we see here is, again, we're getting closer and closer to 1, but we're never actually going to touch it. We're just approaching 1. So if you plugged in like -100, you're going to get a number that's even closer to 1, but not quite 1. All right. Now, why don't you go ahead and try out the next example on your own. Describe those transformations and then graph the function. So go ahead and just, so as you can see, we have 3 transformations. First of all, our graph reflects over the x-axis because of this negative. It shifts left 1 because 1 is being added directly to x, and then it shifts down 3 because of this -3 from the whole function. And now we need to graph it. Go ahead and graph this function on your own. All right, so your function should have been reflected over the x-axis first, then shifted to the left 1, and then shifted down 3. And so as you can see, our function is approaching y is -3 this time. All righty. Let's keep going here. So now in example 3, we're going to take this parent function, y equals 1/2 to the x, and we're going to rewrite it given the following transformations. So it needs to be reflected over the x-axis and shifted up 3 units. So in order to reflect it over the x-axis, I multiply by a negative. So negative 1/2 to the x would reflect over the x-axis. Then to shift it up 3, I add 3 to the entire function. All right, why don't you have a chance now to do, our function is y is equal to 2 times 3 to the x. I want you to shift it right 3 and shift it down 4. So write in the equation what those transformations will look like. All right, so your new function should be y is equal to 2 times 3 to the x minus 3, all minus 4. All right, so now you need to get started on your homework on mathexcelforschool.com, and you also need to get your notes submitted before the end of class. So make sure you get your unit, what lesson is this? The Unit 7 Lesson 4 and the Unit 7 Lesson 3 notes submitted to the assignment in today's folder before the end of class. And if you have any questions as you work through your homework, of course, just let me know. I'll see you guys back in class.